This episode is sponsored by the IoT job site, the world's only dedicated space for applying for and advertising IoT vacancies across the world. Register now for job alerts or get in touch via let's talk at theiotjobsite.com.
Hello and welcome to season 2 of the IoT podcast, and this week is our second AgriTech special. This week is so exciting for me, as I'm delighted to welcome two guests onto the show from Gardin Agritech. Now, if you don't know, Gardin Agritech are developing tools and technologies which are helping enable farmers and growers to maximise their yields, increase the growth optimization, and the main thing, to increase their bottom line. Welcoming today with me the CEO of Gardin Agritech, Sumanta Talukdar, and also Richard Osterloh, the lead systems test engineer. What do Gardin do, and how do you kind of differ from your other competitors out there on the market?
Sure, Jack, I'll take this. So Gardin is a UK-based startup. We're venture capital funded, and Gardin is in the agri-tech space. And fundamentally, we're a full-stack company, so we're doing hardware and software. But fundamentally, the best way to describe it is that we're a high-throughput remote phenotyping company. Now, phenotyping is a word that some people might not be familiar with, but in the agri-tech space, it's the intersection of plant biology, data science, and remote sensing. So the combination of the three is the best description of phenotyping. And specifically what we are doing is we are coming up with the tools, the hardware and software tools, to be able to measure plant physiology. So that's very, very specific to us. So just to clarify, what we are measuring is the physiology of the plant, so the health of the plant. So just like when Jack goes to his GP, she or he is measuring your physiology. So what we are not focused on doing is, what we do use as part of a solution is what other people have already done, which is measuring the geometrical attributes, so color, shape, size, etc. So we're actually measuring the health of the plants that grow our food.
Right, yeah. Richard, do you have anything to add to that? Thanks so much for the sort of overview, Sumanta. But yeah, Richard, do you have anything to add?
To be honest, I think it's pretty much covered it. That's what we do.
That's what it says on the tin. Yeah, I love it. Okay, so I know that what you're doing is quite heavily involved in the indoor growing space and obviously the vertical farming and controlled environment agriculture. So touching a bit more on that. Why is there such a need for vertical farming, do you think? I mean, in terms of things like climate change or nutrient levels or costs, for example?
Yeah, so I think industries and technologies like vertical farming, that's one of them, are one of the solutions to a fundamental problem, right? And the problem is that the world has got to a point, or very soon, within our lifetimes, we're going to get to a point where the world can't feed itself. Now, this has been, recorded on, many scientific journals and publications. But in a very, very top level, the combination of the growing population and the strain on the natural resources and the way that we have produced food for generations past, has stressed the ability of the planet to be able to provide and at the same time absorb waste, to pretty much the breaking point. So I think that's why vertical farming being one of them, but there's, a number of different technologies and solutions that are needed to address this.
Of course. And I mean, one of the key driving factors I've come across working in this space is that reducing the food miles is a huge thing there, and obviously global food hunger is a massive factor in driving this forward. I mean, Richard, what do you see in terms of vertical farming and its necessity in modern culture?
Well, obviously, everything Samantha says is true. There's growing population and a growing need for increased food production. And, when you grow things vertically, obviously you can grow a lot more densely, and you can grow, the required amount without having huge amounts of space taken up. So it seems like an obvious step.
Yeah, certainly. And I mean, I think for me a key thing here is getting government backing behind this, because it's already there and the technology is already there. It's been something that's maybe been a little bit too costly for people to adopt, but I think the more that governments get behind it, the more that farmers and growers see it as being commercially viable, the more it's going to take off and be the future for everyone, I think.
And obviously, on a just general technology excitement level, vertical farming is that nice intersection between technology and traditional farming. So you do get to play with all of the benefits that come from new technology in an old space, and you can make headway in very, very easy techniques that are used every day in sensing that currently don't exist in farming.
Absolutely, yeah. And I think that leads us nicely on to my next question, actually. Can you speak a bit more about the sort of technologies that you guys are using at Gardin?
We're playing our cards a little bit close to our chest.
Yeah.
But what we can say is, I think the best way of looking at, and I think this is, the same for quite a lot of startups and companies, right? Is if you look at the team, right? So if you look at the people within Gardin, and that gives you a very good idea of, these people are there for a reason, right? Of the technologies and the products that we're developing. So, we are a motley crew of people bringing together expertise in sort of physics, plant science, embedded systems, computer vision, machine learning, product design, operations. If you look into detail at all of these, skills that people are bringing and all of that, that gives you an idea of the kind of products we're developing. And like I said, it's no secret that what we are doing is a type of sensing technology, right? So sensors involve physics, they involve biology, because you need to understand what you're measuring. It involves embedded systems, involves computer vision, all of those.
Yeah, and I mean, that comes back to what we were saying before as well, because it is such a traditional industry. And I don't know how you have found it. I know you're, as you said, still playing your cards quite close to your chest, and it's still quite early days for Gardin. But how have you found it, sort of starting the business up? Because it has been such a traditional industry, and implementing these sort of Industry 4.0 technologies to this industry has proved difficult for a lot of my friends in the industry as well. So yeah, I mean, how have you found it?
I think our timing's been pretty good. We're in a very, very interesting point in time now, where there's a number of different factors and agents in the world have kind of aligned, right? So, in no particular order, you mentioned one of them, right? So, local food production is becoming a topic of strategic national interest in a bunch of different geographies, right? So you look at it from the lens of geography and country. So you look at the Middle East, you look at places like Singapore, Taiwan, increasingly in the UK. And of course, all of this has been brought and accelerated by the tangible effects of climate change, wildfires raging across the world, and of course, what's been happening with the pandemic for the last couple of years. So that's one agent, right? And it's a really strong agent, right? The other is that you've got this perfect scenario of pull and push. So you've got pull from the consumers. Yeah. Consumers, increasingly care a lot, want and demand, to know where the food is coming from, how is it sourced, and what the effect on the environment is. And then you've got the push from the food producers, which is also really important, because food producers for generations have enjoyed a monopoly, because even though their existing methods of food production are inefficient and lossy, the fact is that every year the world needed more food, so food producers made more food. But that's got to a point now where they realize that they can't keep doing that. So they are also now motivated to start plugging those gaps, reducing those wastes, and implementing technologies to help them. So, it's like a lot of industries, just relying on one without the other is difficult. But when you have that perfect timing of push and pull, things become a lot easier. So that's definitely what we're seeing.
Yeah, and certainly I think you touched on it there. The nutritional aspect of this is key, because a lot of people's habits are shifting now, aren't they? The pandemic especially has brought that in. And I mean, even before that, health and well-being was just becoming increasingly important in today's society. What people are eating and drinking is very important.
Exactly, and the understanding of the role that diet plays in health. Yeah, This is not a new topic anymore. There's been a lot of research, and actually the real evidence of that is, only in the last sort of decade, there are now EU regulations on the the minimum amounts of certain compounds or chemicals that can be found in certain foods, right? And this could be like fresh produce, it could be tomatoes and apples or processed foods. And these regulations didn't exist about 10 years ago, and they're there now because that link between diet and health is very well understood now.
And just the availability of information as well. People are really interested in finding out, where their food comes from, and not only where it comes from, but what steps it's taken to get to you, throughout the growing process. And if you can track all of that, people are pretty interested in figuring out, where their food actually comes from.
Yeah, absolutely. And it was something that not too long ago people weren't very conscious of, were they? You'd go to the supermarket, you'd buy your onions that have come halfway across the world to get there, and didn't think anything of it. Globalization, a shrinking world, I mean, we all know about this, don't we? So we've just come to accept it. But it is fantastic to see now. I think people are really taking note of it, aren't they?
I think one of the interesting, just sort of like leading on from this, one of the interesting sort of topics to chat about though is that, when you utter technology and food production in the same breath, the obvious and understandably natural reaction is that food's gonna, using technology means food's gonna become more expensive, and it's understandable, right? But people think that. But that should not absolutely be the case, right? So, and that's actually one of the key parts of what we are doing, because it's a very easy, simple thing to explain. By measuring the health of the plant, you can give the plant exactly what it needs when it needs it. And the natural result of that is that A, you get a better quality plant, and B, you're not wasting resources because you're only using what's needed when it's needed. So the two are actually self-fulfilling. A better quality produce at lower cost. They're not exclusive.
That's it. And I think that's one of the key things in making this commercially viable is the bottom line and the yield for growers. They want to see that going up. They want to see efficiency, reducing the waste as well as increasing the yield. I mean, once they can really see that, I can't see how this sort of technology won't just go from leaps to bounds further, and take agriculture into a whole new world. You touched on this earlier, and it's something that I know makes Gardin very unique and is one of your sort of key USPs. So I wanted to ask you a bit more. What do you both sort of see as the benefits for using chlorophyll fluorescence for the phenotyping, as opposed to your more traditional visual spectrum?
Yeah, so the best way of explaining that is, and again, just to sort of recap again, is we're measuring chlorophyll fluorescence is one of the techniques we use to measure the health, the physiology of the plant, right? Now, I'm going to use an analogy to answer your question, right? So, when Jack goes to his GP, right? Your GP, she or he, the first thing they're going to do is, she's going to take your pulse, right? Right? Absolutely. And she's going to ask you about your lifestyle. And then she's going to say, okay, Jack, for the next 2 weeks, I'd like you to, sleep an extra hour, cut back on the proteins, run an extra mile, some changes in your lifestyle. And then she'll say, come back in 2 weeks, and she'll take your pulse again. Because what's really interesting and useful is how your physiology, which is measured by your pulse, is changing in response to your lifestyle or your environment, right? And that tells you that being able to measure that and correlate that with the environment is where the real sort of knowledge lies. But the same thing with plants, right? Except instead of measuring the pulse, you measure the photosynthetic activity, right? So it's a fundamental mechanism in plants turning energy into food, basically, right? And if you can A, measure that really well, which where sensors come in, and B, you can drive strong correlations between that and the environment. Now you can start doing the same kind of things in ag and food production that it happens in humans, and when you're a GP. Now, to touch on the topic of current techniques. So current techniques for measuring the quality of food are based on geometrics, color, shape, size, etc. Right? So we've all seen lots of videos and articles about cameras using machine vision or computer vision to pick out apples and all that kind of stuff, right? So you're looking at stuff you can see by your naked eye, right? Now, if I revert back to the analogy again, and if Jack walks into his GP's and she takes one look at you and goes, "Oh dear,"
that's happened to me before.
That's not good, right? So, and therein lies, well, you don't want that, right? And therein lies one of the benefits, clear benefits, is that by using techniques like fluorescence, you can detect changes in physiology, good and bad, a lot quicker than you'd otherwise pick them up with conventional RGB technologies. And conventional visual technologies, by the time they've picked up a problem, and the problem could be anything. It could be drought stress, it could be nutrient stress, it could be biotics or pathogens. The fact that you can see it means it's too late. So the only thing you can do at that point is effectively throw it away, right? Whereas, of course, if you can detect it a lot earlier, just like in Jack's case, there's a load more other interventions that can be applied.
Yeah, and Richard, I'd love you to sort of play on this more, because absolutely there's so many factors there, isn't there? You're not just looking at one thing like nutrient levels or whatever. You're looking at so many different factors that come into the growing conditions of the plant, and you want that optimum growing condition, don't you? So all of these different factors combined, especially with a lot of indoor farms having multiple rows of different plants that have different needs, this sort of technology is so important for preempting any problems you may have. So yeah, I mean, Richard, would you like to expand on that at all?
Yeah, I mean, fundamentally the technique's not exactly, new or novel, but the current technology that you can get, off the shelf at the moment is either like very big or expensive or requires physical contact with the plant, or just generally inflexible. And also when you take these measurements, normally you'd have to have like a pretty deep understanding of the biology that's happening within the plant, and B, the technology that's used to measure that biology, which is cutting down. You can't just have anybody come off your shop floor and take this measurement. So the difference with our technology really is that we provide the insights from having a team of all of those experts, and combine the collective knowledge of all of them to give concrete recommendations of actions that should be taken by a particular user or somebody who employs or adopts the sensor. Because farming operations in general are like very big. They cover huge areas of land, or they're quite dirty or harsh environments. And if you have like a big expensive sensor that requires either you to bring the plant to the sensor or you to go to the plant to take a measurement, it really only works well in a sort of research lab facility. So with a distributed system and a network of sensors, you can enable bringing intelligence to the plant in order to take a good measurement and understand well what you need to do in order to take a measurement there at the plant, and then distribute that data outwards such that you can have your big expensive machines that do the processing and greater trending away from those harsh environments.
Yeah, of course. Yeah, absolutely. I think you've kind of just answered my next question slightly there. But I mean, this is the IoT podcast, of course, so I have to ask you about IoT. And I think a good sort of question would be, I mean, how much more do you think IoT can do within AgriTech?
Yeah. So I mean, for me, IoT is about having a large number of sensors distributed through an area of interest. Yeah. So with a distributed network, you can gain like specific insights of variations within the particular area that you're measuring. And in AgTech, that's very key, because you can make decisions that are plant-led. You can instead of just having sort of time-based recipe decisions that people use at the moment, where you can enable closed-loop control of biological systems that don't make the assumption that all plants are the same always. So in more general terms, you can let the plant tell you when it needs water or nutrients or generally feels unwell, rather than assuming that this plant that you're looking at now is the same as the one that you grew last week. So I think that's where IoT really comes in. You don't have to assume. Yeah, I mean, you can take the analogy of cooking with a recipe. You have the series of steps that you need to take in order to complete the recipe, but at the same time your eggs might not be the same, or your milk might be a different temperature or whatever. So you kind of have to have the knowledge to look at the situation and have some sort of judgment call that says, oh, actually something's a bit different here, I need to tweak this, or I need to taste, I need to add a bit of salt. And that's kind of what we enable, is the ability to know what you're looking at while you're looking at it, and not make assumptions that all recipes and all steps must be followed exactly the same way forever, and tweak as you go.
Yeah, and we've touched on that already, haven't we? I mean, when it initially came into play, sort of indoor growing and urban farming, whatever you want to call it, I think it was more just a sort of exciting new opportunity that people were really, as I say, excited to get involved in, but they hadn't even really considered how IoT and Industry 4.0 solutions could be implemented into that. And again, I think robotics and automation as well is something now that's also pushing its way in a lot more. Originally, I think it was just a case of, hey, let's grow indoors and make it grow vertically. And now, I mean, it's just exploding, isn't it? And there's so many more different opportunities in this space. Sumanta, did you have anything to add on the sort of where you think IoT is going to implement itself into AgTech?
Rich has covered the brunt of it, and IoT actually is a big part of the problem and solution, right? And Richard touched upon this absolutely, which is, farms, be it vertical, be it greenhouses, be it field farms, they're huge, right? And you can't go lugging a sensor around to the plants, or you need and previously it's not been possible for phenotyping. So for sensors such as soil sensors, temperature sensors, humidity sensors, it's already accepted and known that all of these are deployed as distributed systems because that's what's needed. And that has not been possible by phenotyping in the past before, because the instruments have been unwieldy, they've been expensive, they don't work remotely, they don't work in harsh environments, and they require too much data. And sometimes people forget that data costs money, or crunching data costs money. So and we're plugging that gap. So we're basically aiming to bring phenotyping into real operations in food production by bringing distributed systems.
Yeah, thanks so much for that. Yeah, absolutely. So I guess sort of a stat that, I mean, it's not really a statistic, but something I've read a lot and that is being flyed around a lot at the moment is that sort of by 2050, I mean, this is all very rough estimations, isn't it? But the shortages of water and land combined, as well as obviously ever-increasing demand from population growth and economic growth in lower economic countries at the moment, all of this combined is going to create a major global food shortage. And I think, Sumanta, you did touch on this briefly at the start of our conversation. So I guess my question from that is, how far do you think kind of AgTech can be deployed, and what does the future look like within AgTech to solving these kind of global issues that are going to arise?
So, again, sort of to answer that, but, harkening back to what we were discussing earlier on, that, we are seeing all the agents coming into play, on a consumer level, on a producer level, on a government level, on a geographical level, which is good because, it's a huge problem. One person and one agent can't solve it on their own. So, but therein lies again, the good news, which is a lot of clever people are now starting to focus their attentions on this, right? So, we're doing what we're doing. People in indoor farming are developing their technologies. There's people looking into the relationship between microbiomes and soil health. And this is all good news because you need all of these people, very smart people, looking into all of these, right? And therein lies the good news, because I do believe that it's going to take concerted effort by lots of people working on various parts of the overall problem to solve it. And I'm optimistic because we're seeing great things happen already.
I'm glad to hear you're optimistic, Sumanta.
Yeah, and in the same way as you would probably need to fuse the knowledge of many different people, the fusion of many different types of data really is something that can help us in this regard, is that you don't just look at the temperature and see how the temperature varies over time. You fuse many different techniques, and the combination of those really gives you the insight as to what's going on, what you might need to do, but also things that you may not have thought of yet.
Absolutely.
Yeah, absolutely.
So, I mean, to try and get some kind of prediction or specific from one of or both of you, I mean, to go back to that question, I mean, have you got any sort of visions of where you see AgTech going? Have you got any, I know in terms of Gardin, the tech you're using is still quite close to the chest, but have you got any ideas in your mind of different areas that AgTech could start to, I mean, I guess I'm rephrasing the question slightly of what I've just asked, but I just thought if you had any specifics in mind that you thought AgTech could really help whether it be, I don't know, drone technologies or soil monitoring technologies or whatever it may be. But yeah, do you have any sort of specific ideas you think you could share?
I think that the kind of work that we're doing and other people are doing, the inefficiencies exist throughout the supply chain,
Right, yeah.
not just pre-harvest, right? So to bring it back to our world, right? What we're doing is measuring how food is grown differently, right? Actually measuring the health of the plant, the nutritional density of the food, right? And like I said, current metrics of quality are size, color, shape, right? And what I'm about to say next is based on an assumption, right? You either believe it or you don't believe it, and that's either is fine, right? If the assumption is that the current metrics of measuring food quality are wrong, right? So we're not then if the answer to that is yes, I believe the current metrics are wrong, well, those metrics are used to judge the quality of food throughout the supply chain, picking, sorting, processing, which batch of apples should go to 50 miles away, which should go far. These are all based on metrics. And if you're saying those metrics are wrong, it means that those metrics are used throughout the supply chain, and therefore the inefficiency exists literally from seed through to shelf, right? So I think just on that one particular topic, AgTech, has an immense role to play. And we're only just getting started.
Yeah, that's one of the key things you've said there. I think we are only just getting started. A lot of my friends in this space are taking baby steps to something much, much more exciting and hopefully going to save this planet in many ways, more ways than one. But look, thank you so much, both of you, for joining us here today. It's been an absolute pleasure. And yeah, we will see you both very soon, I'm sure. It's been an absolute pleasure again.
It's been great, Jack. Thank you.
Thank you very much. So, thank you so much, Richard and Sumanta. What a great episode that was. If you'd like to find out more information about Gardin Agritech, then just go to their website, gardin.co.uk. Alternatively as well, if you'd like to follow us more, please feel free to like, subscribe, and find out more information at the IoTpodcast.com. Thank you very much.